matrices class number 2. Lesson number 3, class number 2. We are going to see the types of matrices. Types of matrices. So types of matrices. So first, so don't write the examples, so we are comparing the matrices. For example, A is equal to 1, 2, 3, 4, 5, 6. So is the given matrix. How many rows are there? So it is said to be first row and it is said to be second row. So once again I am repeating, the rows horizontal lines are said to be rows. So the rows are counted from top to bottom. So like this, 1, 2, 3, 4, etc. So now it is said to be vertical lines are said to be columns denoted by C1, C2, C3, etc. So here the columns means vertical lines. Columns are counted from left to right like this, 1, 2, 3, etc. So this matrix contains 2 rows and 3 columns. 2 rows and 3 columns. Then its order is 2 cross 3. It can be read as 2 by 3 now. 2 cross 3 or it can be read as 2 by 3. So 2 cross 3 or 2 by 3. First number denotes number of rows. Second number denotes number of columns. So now I am giving one more matrix. Suppose B is equal to 1, 2, 3, 7. Now see this one. How many rows are there? How many rows are there? So now first row and second row. Row 1 and row 2. And it is said to be column 1 and column 2. How many rows are there? 2 rows and 2 columns. So its order is 2 cross 2. 2 cross 2. So see one more matrix. C is equal to 1, 2, 3, 4, 5, 6, 7, 8 minus 4. You may write any real number. You may write any real number. So now see this one. Here row number 1 and it is row 2 and it is row 3. Since rows are counted from top to bottom. So now it is first column, second column, third column. Its order is how much now? 3 by 3. So means here this matrix is said to be a rectangular matrix. Rectangular matrix. So don't write this one. Just I am comparing the matrices. Types of matrices. Don't write the notes now. It is said to be rectangular matrix and it is said to be square matrix. And now don't write the notes. Now it is said to be square matrix. How we are defining the square matrix and rectangular matrix? So I am giving one more example here. Suppose C. Matrix B is equal to 1, 2, 3, 4, 5, 6, 0, 7, 1, 2, 5, 6. So now it is row 1, row 2 and row 3 and it is first column, second column, third column, fourth column. 3 rows and 4 columns. It is also said to be a rectangular matrix. Rectangular matrix. So what is the meaning of rectangular matrix? If number of rows is not equal to number of columns. A matrix is said to be a rectangular matrix if number of rows is not equal to number of columns. Say 2 not equal to 3. Simply you can say, so in yesterday's definition, m not equal to n. So m are rows and n's are columns. If rows number of rows not equal to number of columns, then the matrix said to be rectangular matrix. Here 2 rows and 2 columns. Number of rows is equal to number of columns. If the matrix is said to be a square matrix, if the number of rows in the matrix is equal to number of columns. Now we have 2 types of matrices, no? But so many types of matrices are there. Just I am giving the 2 types out of those matrices. So what is the definition of rectangular matrix? A matrix is said to be a rectangular matrix if number of rows in the matrix are not equal to number of columns. So like whatever square matrix, number of rows is equal to number of columns, and is said to be a square matrix. So first I am writing the rectangular matrix. First slide heading is rectangular matrix. Rectangular matrix. Rectangular matrix. So write down the definition. So a matrix is said to be a rectangular matrix. The matrix A, better to write A now. A matrix A is said to be rectangular matrix. If number of rows in a matrix is not equal to number of columns. Number of rows in a matrix is not equal to number of columns. That is m not equal to n. We can give the simple word now. M not equal to n. That is m not equal to n. In the order of a matrix, m not equal to n. Now what about the example? So here the example now. Example. A is equal to 1, 2, 3, 4, 5, 6. Next example 2. A is equal to, or you can write one more better. B is equal to 1, 2, 3, 4, 5, 6, 7, 8, minus 1, 0, 5, 3. Here order is what? 2 pi. Here order is 3 pi. We will give the one more example. Is equal to 1, 2, 3. Here order is 1 row, 3 columns. Next example is last example I am writing. Matrix D, or you can write P is equal to 1, 2, 5. Here 3 rows, 1 columns. So now see here. Suppose some x is equal to, it is not a matrix. It is not a matrix. Why? Because no number is there in the bracket. It is not a matrix. Don't write like this. We have to arrange some numbers. So write down the 4 examples. Here matrices can also be enclosed as open brackets. No? You may write open brackets or closed brackets. You may use any one. So So next identity is square matrix, or you can write row matrix. Square matrix. The row matrix means this one is row matrix. It is column matrix. Next one, square matrix. Square matrix. After then row, after then column. Next identity is square matrix. A matrix capital A is said to be a rectangular, square matrix. Square matrix, if number of rows in a matrix is equal to number of rows in a matrix is equal to number of columns. Means here n is equal to n. M is equal to n. Now I am giving the examples for the square matrix. So 2 by 2. So 3 by 3. So you may write like this. Number 9 or 6. 1 cross 1 is also square matrix. 1 row, 1 column. So you may give the one more example like this. A is equal to A11, A12, A21, A22 is also a product 2 cross 2. What is the meaning of A11? What is the meaning of A11? First row, first column. Whatever this one. First row, second column. Here, first row, second column. Second row, first column. Second row, don't confuse here. First number gives row. Second number gives column. Means here, one means first row, first column. First row, second column. Next example. Suppose B equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Order is out. 3 by 3. Now what is the meaning of 2, 1? Second row, first column. Second row, second column. Second row, third column. Here it is. Third row, since first row, second row, third row, first column. Third row, second column, etc. So these are most important examples. So copy these two now. So if I write only one, cross one. Suppose 8, A1. Just you may write A1. First row, first column. So what is the meaning of 8, 2, 3 now? Second row, third row. Next heading is row matrix. Row matrix. A matrix is said to be a row matrix if it contains only one. If the matrix contains or you can write have only one. Only, underline the only one row. So give example Anna. Suppose A is equal to 1, 2. It is a row matrix. 1, 2, 3 means first row take M is equal to 1. So here meaning is what? M should be 1. No details about N. M should be 1. Example. Suppose P is equal to 1, 2, 3, 8. 1 cross is also row matrix. One row. It contains only one row. Underline only one row now. Underline the first row. Only one row is there. But columns are 3 here. First column, second column, third, 4 columns. First column, second column, third column. Next heading is column matrix. Only one column. The matrix is said to be a column matrix if it contains only one column. A matrix is said to be a column matrix. Only one column. So give an example now. Only one column. 1, 2, 7. 3 rows, 1 column. Means here n is equal to 1. N should be 1. Next here. Matrix P is equal to 4 rows, 1 column. Next side is principal diagonal. Principal diagonal. Principal diagonal means series. So just I am giving the concept of principal diagonal. For example, A is equal to 1, 2, 7, 8. So this diagonal is said to be principal diagonal. Here order is 2 cross. Now taking B is equal to 1, 1, A 1, 2, A 2, 1, A 2, 2. So this diagonal is said to be principal diagonal. Both are same, no? Just I am changing the numbers inside the matrix. Next, matrix P is equal to 1, 2, 3, 4, 5, 6, 0, 1, minus 1. No need to write maintain the serial number now. Just you are writing the random numbers. Now this diagonal is said to be principal diagonal. Now next example. Suppose Q. Matrix Q is equal to A11, A12, A13. What is the meaning of A11? First row, first column, first row, second column, first row, third column. Next one is A21, A22, A23, A31, A32, A339. So here this one is said to be principal diagonals. Now one more example. Okay, right, last one. So how can you define the principal diagonal? So first the diagonal from first row of the first element of the first row. Na? The diagonal from first element of the first row to last element of the last row. Once again, in the first row, first element. In the last row, last element. The diagonal from first element of the first row to last element of the last row. So write down. So it is not possible. So principal diagonal is possible for only square matrices. So don't confuse here. Don't take rectangular matrix. Don't take rectangular matrix. In a rectangular matrix, principal diagonal is impossible. Principal diagonal is not possible. So let capital A be the given square matrix. Given square matrix. So already condition is given. Given matrix should be square. Underline the square matrix. So the diagonal from first element. The diagonal from first element of the first row. Of the first row to the last element. The last element. Element means number, don't confuse. Last element of the last row is called a principal diagonal. Let A be the square matrix. Given square matrix, the diagonal from first element of the first row. First element of the first row to the last element of the last row is called. Now give the examples. Give the example 1. 2, 3, we are 2 now. 3 and 4. So you can give the one statement. In a rectangular matrix, principal diagonal is not possible. Give the statement Anna in the note. In the rectangular matrix, the principal diagonal is not possible. In the rectangular matrix. Principal diagonal is not possible. Write the examples. next identity is trace of a matrix. Trace of a matrix. Let capital A be the given square matrix. Given square matrix. The sum of the elements of the sum of all the elements. Sum of all the elements. Sum of all the elements of a square matrix is called the trace of the matrix. Trace of the matrix. It is denoted by trace A. Or simply TRA. Now see this one. Here trace of A is equal to how much? Trace of A is equal to 1 plus 8. So answer is 9. Add only the elements of principal diagonal. That is said to be trace. Here what is the trace? Here trace of A is equal to how much? A11 plus A22. All the elements of, see this one, that A be the given square matrix, the sum of all elements of principal diagonal. All the elements of principal diagonal. So please see this one, please see the definition here. All the elements of principal diagonal. Just principal diagonal. See the definition once again. Students, see the definition once again. Let A be the given square matrix, the sum of all the elements of principal diagonal. So underline the principal diagonal. Elements of principal diagonal. Underline the elements of principal diagonal. So now here trace is what? Here trace is what? For example, 1, 2, 3, 4, 5, 6, 7, 8, 4. So here trace is equal to trace of P is equal to principal diagonal. So this is said to be principal diagonal. No? 1 plus 5 plus 4. Answer is 10. So what about the next example? Principal diagonal. A11, A12, A13, A21, A22, A23, A31, A32, A331. So trace of Q is just add the elements of principal diagonal. So just add the elements of principal diagonal. A11 plus A22 plus A33. So very most important in the examination point of view, they will ask the definition of trace of a matrix. So give the star mark. So very important in the examination point of view. very simple definition. No? The sum of the elements of all the all the elements of principal diagonal. Just see the definition once again. Next one is scalar matrix. Scalar matrix. Next one is scalar matrix. Or you can say, diagonal. Before that, write a diagonal matrix. So next one will be scalar. First diagonal matrix. First copy the diagonal matrix. After then scalar matrix. Then order will be fair. First write the diagonal matrix. After then scalar matrix. Then order will be easy now. So see this one. The square matrix. Capital A is said to be diagonal matrix. Diagonal matrix if all the elements of a matrix are 0 except the elements of principal diagonal. Elements of principal diagonal. Okay. So understand now? Matrix A is said to be a diagonal matrix. All the elements of a matrix are zeros, except the elements of principal diagonal. Give the example. 0, 0. So see this one. 0 and 0. Zero, zero, zero. 0, 0, 0. Here 0, 0. 0, 0, 0. Diagonal matrix means only diagonal elements are there. Of course, it can also be written as diagonal of 1 8 none. It also written as diagonal of A11, A22. So it can also be written as, give the one more notation for it. Diagonal of 1 5 4. So it can also be written as diagonal of A11, A22, A33. No need to mention the non-diagonal elements since always they are zeros. So it is an important notation when you are doing the problems. So it will be help personal. Some others, the diagonal matrix is taken as like this. Give the one more notation here. See this one. Non-diagonal elements, non-principal diagonals. Except the elements of principal diagonal, remaining are zeros. When principal diagonal elements are available, we can create the original form of the matrix. No? When principal diagonal elements are given, we can create the full form of the matrix by taking remaining elements as 0. Next, you may write scalar matrix. Next, you may write scalar matrix. So, important definition. The diagonal matrix is said to be, and the square matrix is said to be. The square matrix is said to be scalar matrix. If all the elements of a matrix are zeros, better to write diagonal matrix. The diagonal matrix can place it to be a scalar matrix if all the elements of principal diagonal, all the elements of principal diagonal are equal. So compare the definition. Basically it should be a diagonal matrix. The diagonal matrix can place it to be a scalar matrix if all the elements of principal diagonal are equal. Just see this one. 8 and 8. 8 and 8. Next one is on see this one. Example 2. B is equal to 5 0 0 0 5 0 0 0 5. Example 3. Minus 6 0 0 0 minus 6 0 0 0 minus 6. See this one. All the elements should be equal in a principal diagonal. Here A11 equal to A22 equal to 8. So give the example here now. So see this one. All the elements of a principal diagonal are same. Means every scale. So you can give the definition. Every scalar matrix is always diagonal matrix. No? Every scalar matrix is a diagonal matrix. But diagonal matrix need not be a scalar. Next one, zero matrix, or you can write null matrix. For a rectangular matrix, scalar matrix is not possible now. So write the null matrix. Or zero matrix. The matrix capital A is said to be then the matrix is said to be no need to write name now since null matrix is write O. The matrix is said to be null matrix if all the elements in the matrix are zeros, it is denoted by O. Null matrix is denoted by O. So example, O 2 by 3 is equal to example, O 3 by 3 is equal to so means null matrix may be rectangular matrix or square matrix. Null matrix may be either square or rectangular. Next one is identity matrix, or you can say unit matrix. Identity matrix or unit matrix. So the diagonal matrix is said to be diagonal matrix is said to be identity matrix if all the elements of principal diagonal are unity. So that is one. What is the meaning of unity? One. All the elements of principal diagonal are one bracket or that is unity. So see this one. Example. It is denoted by I. Capital. So now give the example. A 2 by 2 null matrix, identity matrix 1 0 0 1. I 3 by 3 null 1 0 0 0 1 0 0 0 1. So see this one. So give the I 4 by 4 now. Give the I 4 by 4. Give the example of I 4 by 4. One zero 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 0100 0010 001. Note the n cross n identity matrix is denoted by I n cross n. So this is the principal diagonal. All the elements of principal diagonal should be ones. Next one is upper triangular matrix. Next side thing is upper triangular matrix. Very important in the examination point. The square matrix capital A is equal to Aij is said to be upper triangular matrix. Is said to be upper triangular matrix if Aij equal to 0 for I greater than j. If Aij is equal to 0 for I greater than j means so. Means just see down. What is the meaning of Aij? Ith row and jth column. See this one. Example. A11 is equal to A11, A12, A21, A22 is a triangular matrix, or you can see the upper triangular matrix. If see this one. Here A1 equal to 1 now. Here 1 not equal to 0. So write the 1 2, 1 3, 2 1, 2 3, 3 1, 3 2, 3 3 is upper triangular matrix. If therefore see this one, I should be greater than j. So first number should be greater than second number. First number this one now. This one should be 0. This one should be 0. This one should be 0. A21 equal to 0. A31 equal to 0. A32 equal to 0. Here 1 equal to 1. 1 less than I less than j. I less than j. I equal to j. I less than j. I less than j. So give that one more example now. A is equal to 1 2 3 0.7 0 0 6 is upper triangular matrix. See this one. Since A210, A310, A320, since A210, A310, 320. So copy the definition and give the example. Once again I will explain the upper triangular matrix in the next class.